Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. And here you have information about online seminars for exams P, FM, LTAM, and IFM that I teach, and the study manuals that I wrote for those exams. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to our program, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam FM on financial mathematics. Donald takes out a loan to be repaid with annual payments of $500 at the end of each year for 2n years. The annual effective interest rate is 4.94%. The sum of interest paid in the year 1 plus the interest paid in year n plus 1 is equal to 720. Calculate the amount of interest paid in year 10. And here's the solution. So the balance of the loan at the beginning is 500 times A angle 2n at 4.94%, and the interest paid on that in the first year is I times that. And of course, A angle 2n is 1 minus v to the 2n over I. Well, we know the interest rate, but I denotes it as well. But the point is that it will cancel, and this will become 500 times 1 minus v to the 2n at that interest rate of 4.94%. And the interest paid in year n plus 1 is I times 500 times A angle n, which is the balance before year n plus 1, at 4.94%, and the same way that's equal to 500 times 1 minus v to the nth at 4.94%. The sum of the two is what you get when you add them, but we know it to be equal to 720. Now let us write z for v to the nth, v being the discount factor for the interest rate of 4.94%, and then the equation that we have becomes 500 minus 500 z squared plus 500 minus 500z minus 720 is equal to 0, or we can just simplify it and write it as 25z squared plus 25z. If we move it to all of the things that starting with 500 minus 500z squared, if we move it to the other side, or reverse the order, or multiply by -1. So it's now both the coefficients of z squared and z are negative, but we want them positive, that we can multiply everything by -1 and then divide everything by 20 and get this, or just move everything to the right hand side, divide everything by 20. We would have also 500 plus 500 minus 720. Subtract that, divide by 20, and we would get 14. So the result is that after we simplify everything, this becomes 25z squared plus 25z minus 14 is equal to 0. This is a quadratic equation. The solution is z equals -25 plus minus the square root of 625, which is the square of 25, minus 4 times 25 times -14, which is 1400, divided by 2 times 25, which is 50. And this comes out to be either -1.4 or 0.4. Of course, only the positive solution is feasible, so that z, which is v to the nth, has to be 0.4. So this really means that 1.0494 to the power minus n is equal to 0.4, and then you can take the natural log on both sides and solve it, or you can just use a calculator and figure out that n is equal to 19. Therefore, the interest paid in year 10 is I times 500 times A angle 29 that's the remaining number of payments before the beginning of that year, and that's equal to 500 times 1 minus v to the 29th at 4.94%. And then that's just a matter of calculation. This comes out to be 376.50, which is answer D. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.